4 billion cubic meters of natural gas, which is being flared per year. That's like 10% of the natural gas that we produce in Nigeria. We flare it. And if you're flaring 10% of something, let's say you produce 100, let's use cocoa, and you waste 10%, that's a missed business opportunity. Of course, that could be sold. Of course, that could be marketed. It could be converted into something more useful. It could be converted into something more useful, and that's where hydrogen comes in. Okay. Yes. Okay, so all right, so this is just a simplified diagram of everything that we've been working on. As you can see, yeah. Is it better? Yes, it is. All right, so as we can see, we have flare gas, and we know that gas is flared for various reasons. Sometimes the volume of the gas that's produced is not economical enough for you to perhaps feed it into the pipeline. Maybe the composition is not good enough, etc. Now, increase it a little bit. Okay. Can you hear me? All right. Now, in the spirit of all right. So, in the spirit of what Zenergy tries to do, I think that one of the best solutions to natural gas is modular solutions. Modular solutions are small-scale solutions that can be rapidly deployed, and they do not need as much capital expenditure as bigger projects. That is why we have a modular reactor here. Now, what this modular reactor does is that it simply just splits methane into carbon and hydrogen. We have the carbon at the bottom of the screen, and then we have hydrogen as well. Most other ways of utilizing natural gas, they involve convoluted projects, they involve larger scale projects. However, when it comes to methane pyrolysis, using methane pyrolysis to create hydrogen, it simplifies that process. All we produce is hydrogen and carbon. Now, the beauty of this project is that it can be produced using energy from the sun, because most other projects in the Niger Delta, they actually use the gas that we're trying to diversify away from, and it ends up releasing carbon dioxide into the environment. Now, powering this reactor with solar makes it very easy for hydrogen to be produced. Now, you may be asking, why are we trying to produce hydrogen? We're trying to produce hydrogen because, first of all, if we do not produce hydrogen and we flare gas, we are going to pay penalties, we are going to pay fines, we are going to pollute the environment. So it not only constitutes ecological damage, but also economically, we need to move away from flaring gas. Now, why hydrogen itself? Hydrogen is very useful. Predominantly, you can use hydrogen for energy. You can use hydrogen in your cars. I mean, there are cars that are being retrofitted to use hydrogen now, and the only waste product that they have is water, as opposed to other cars where their waste products, their emissions, we know about emissions of cars is a lot. But when it comes to hydrogen, the only waste product is water. And if we can produce such a thing from waste, I see no reason why we shouldn't go along with that. The second reason why we should produce hydrogen is that hydrogen is a feedstock. When we say feedstock, it is something that is used to produce other further chemicals in the chemical process life cycle. For example, you can use hydrogen to produce ammonia. I'm sure that we all know that ammonia is one of the predominant chemicals that are used to produce fertilizers. We also know that hydrogen can be used to produce methanol. Methanol, as we know, Zenergy is also working on a methanol plant. We know the importance of methanol. Methanol is an important feedstock for a lot of chemicals when it comes to chemical process engineering. So what this method is telling us is that we can simply take flared gas, convert it into hydrogen, power it by solar, and make sure that our carbon emissions are net negative. And then the beauty of the paper is that it's not just an idea, but there's also a techno-economic analysis. The display is not clear, but if we look at the numbers, we can see that we're producing it at less than $6 per kilogram of hydrogen. That $6 per kilogram of hydrogen is the benchmark that has been set globally for hydrogen production worldwide. In other countries, say in Europe, they are not able to achieve hydrogen prices of less than $6 because they don't have the abundant natural resources that we have. However, when it comes to Nigeria, we haven't utilized our natural gas resources to produce hydrogen because we do not have the awareness and the technological know-how to do this, as well as the massive capex that is required to launch projects like this. So, to simplify it, we work with Zenergy's modular solutions, a modular reactor that can be rapidly deployed and it does not cost anything, or it costs significantly less than building a plant from scratch. So, I will move on to the subject of today's paper, if I can find my pointer. Okay. All right, so for this paper, what we are looking at is how can we transport hydrogen from point A to point B, and what is the best way to do that. Now we know when it comes to transporting gas, hydrogen is a gas and it can be transported just like we transport it can be transported just like we transport natural gas. However, transporting hydrogen as a gas, it has a lot of technical issues. Hydrogen is very small, and so you cannot use the same pipelines used to transport gas to transport hydrogen because it's going to leak and escape. And also, hydrogen is very flammable. So if it leaks and escapes, it can cause a lot of issues. So we said, no, we don't want to use pipelines. The best way to transport hydrogen is to use trucks. Now, we have two options. We have compressed hydrogen and liquid hydrogen. Now, compressed hydrogen, as we know, we can put it in a tank, compress it, and put it in a truck. That way, it's easier to transport than having to build an entire pipeline system to transport hydrogen. Now, the advantage of compressed hydrogen is that it takes less energy to compress, but the disadvantage is that you also transport less volume. Now, when it comes to liquid hydrogen, you can transport more volume, but the energy it takes you to liquefy hydrogen, you need to take it to cryogenic temperatures of minus 253 degrees Celsius. That energy that it takes to liquefy it now, we need to factor it in. And all of these have costs. So this paper is trying to quantify what is the best way of transporting hydrogen and how much will it cost us. So this is the formulation that we were able to come up with, where we talk about how much it will cost to either liquefy, which is the energy penalty. We're also talking about the operating costs part of the trip, which is like the cost of the fuel that the driver, the cost of logistics, etc. And then there's also the fixed cost per trip. And then we look at some constraints that this formulation has to abide with. Very importantly, this research was done for the Warri-Port Harcourt corridor. So we're looking at hydrogen production in Delta State and then transporting it to Port Harcourt where it can be used industrially. So the conclusion that we arrived with is that for the distance of 170 kilometers, which is the distance between Warri and Port Harcourt, the most economical way to transport hydrogen is using compressed hydrogen. If you use liquid hydrogen, you will run into too many costs, and at the end of the day, that affects your bottom line, it affects your revenue, it affects your return on investment. So for shorter distances, it is preferable to transport your hydrogen using compressed hydrogen. And then this is just a breakdown of transport and logistics, like what this cost is divided into. That this cost now, what is divided into? Majority of it is the transport cost, but then we have a section for how much it costs to actually compress or liquefy it. Moving on to the next slide. Now, we did a sensitivity analysis. What the sensitivity analysis shows us is that at larger distances, if your distance goes above, if your distance goes above 250 kilometers, then it becomes more economical to use liquid hydrogen. So at less than 250, it is preferable to transport your hydrogen compressed. Above 250, it's preferable to transport your hydrogen liquefied. Why is that? Because with liquefied, you can carry more volume. And above that distance, the effects of trying to liquefy, the higher energy penalty cost is offset by the fact that you can transport more hydrogen. So then we're also able to expand this, do a nodal analysis, and in conclusion, the next direction I believe that we should go as a company is to try and align ourselves with the global shift towards energy. And when we align ourselves in that way, it doesn't mean that we diversify from our assets. It doesn't mean that we have to abandon our gas reserves. It doesn't mean that we have to abandon our existing infrastructure. Instead, we can build bridges between the present and the future. And one of the best ways to do this is by using hydrogen. We have the resources that are needed. We have the resources. We have the ideas. The ideas are being disseminated right now. And what we can do is that we can start investing, we can start listening, and then we can start paying attention to the future of energy. Thank you. Any questions? Does anyone have any?
Thank you very much, Campbell. Please let's put our hands together for him for that wonderful presentation. Thank you very much. All right. Do we have any question for him concerning the presentation he just made? Can you hear me? Okay. So do we have, yes, a question?
Okay, so your feed gas was methane. So did you consider transporting hydrogen and compressed gas? Did you make that comparison? And then which one is cheaper to fractionize and get a hydrogen, and then what compared to natural gas? Secondly, the carbon content from the methane gas fractionization, you didn't say anything about it. What use is it going to be? Is it economically useful or what? Thank you.
Well, those are two very good questions. I will start with the second. So, actually, the idea that is being disseminated here is a modular reactor for converting methane to hydrogen. Of course, one of the issues with flaring gas, one of the reasons why we flare gas is because that gas might not be, the composition might not be compatible with what we need to maybe send to NMDPR or send to our regulators or to send to the NGIC. So, of course, there needs to be some purification. However, extensively, we all know that CO2 to methanol processes are very possible. So it's still a life cycle that continues. Like if you purify your methane that has high CO2 content, you then use that CO2, combine it with hydrogen, you are still able to get methanol, utilizing CO2 as a waste stream, actually converting it into a feedstock, combining it with hydrogen to get a useful product, which is methanol. So your other question about comparing hydrogen and compressed gas, well, this study focuses on hydrogen. Of course, there are many studies that compare gas and hydrogen, but I think that when it comes to energy, perhaps hydrogen cannot compete with natural gas when it comes to energy. But when it comes to being a feedstock for other chemical processes, as being a feedstock for ammonia, being a feedstock for methanol, hydrogen cannot be replaced in those processes. And that is why it's important for us to produce hydrogen through this. Yes. Any other question?
As a follow-up, carbon, the storage of carbon is very difficult. So most times they store as a solid or whatever. So that's what I'm saying, because if you extract the carbon, what you do with it is still a hazard to that environment, depending on how you store it. So, okay, but you do study about that on how you can actually process it more to make sure that we store it very well.
Well, this paper is actually the second in a series of papers trying to build a system where hydrogen can thrive based on Nigeria's conditions. So, of course, we know that underground storage of carbon is possible. However, the solution I'm focusing on here is instead of storing that carbon, we can use it to make sure that there's none left over, which is that process of CO2 to methanol. It's not detailed here. I was actually invited to present that in Singapore earlier this year, but I couldn't go because of financial issues. So there's a lot of solutions that come to, instead of trying to store the carbon or instead of flaring it, we can use that carbon, combine it with hydrogen to produce methanol. So that's a cheaper way of producing methanol than the traditional way of Fischer-Tropsch or gas to liquid. So that's something that we're looking at. It's, of course, a frontier of research and a lot of funding, a lot of ideas we need to go into that. But I think that using carbon dioxide instead of wasting it or storing it is by far the cheaper way of utilizing. Yes.
All right. I think, thank you. That was one of the questions I want to ask. But my second question is that I know we're all moving to green energy or blue energy, and hydrogen is blue energy or something, right? Okay, so greens, thank you. So the waste product from hydrogen is actually water. Now, it's assumed that the world is covered with 70% of water, right? And the future is that if we go, like, let's say 30% energy we are using now becomes hydrogen, that volume of water, what is the plan for that volume of water? Because it might seem not harmful right now because it's just water. But when we now have water in excess, what is there a plan? Is there anybody thinking about that in future or something?
Actually, so when I say water, I don't mean liquid water. I mean steam. So it precipitates and then it falls back as rain. So it's not like there's a water deposit somewhere that you would need to. Yes, but the water in the earth is constant. The earth is a closed system, so we can't have excess water as a result of using more hydrogen. Yes.
Thank you. Okay, hydrogen is very, very unstable. So, did you talk about? You mentioned about the safety about it. You only talk about the cost, but what about the safety? Did you factor it into the cost planning, especially when you want to transport to the road trips? Because considering you mentioned Warri Port Harcourt road, considering the death trap and the unstable nature of our road, I don't know whether you consider that in your simulation on the cost. Thank you.
Safety actually is one of the major reasons why hydrogen has not been widely adopted, because of course we know hydrogen's flammability is very wide, so a little spark can cause like a big explosion of hydrogen. Now, yes, safety is something that needs to be incorporated into the cost, and you are right to point that out. I think that's something that is subject to further research, the cost implication of trying to be safer for hydrogen. However, in countries like Germany, the Netherlands, in northern European countries, they already have trucks that can transport hydrogen, and they've taken into account these safety considerations. So if you were to develop your own trucks from scratch, then you would have to consider that safety issue. But maybe if you were importing those trucks to transport hydrogen, then you take into account that those things have already been covered. So yeah.
I just have one question. Can you hear me? Yeah. Okay, so have you thought about hydrogen blending, like blending it with CH4 in a specific ratio, to try as much as possible to see if the transportation of this hydrogen will be possible in the pipeline instead of having its own form of transportation?
Yes. Okay, that's a very good question. So hydrogen blending is something that a lot of people have looked at, and the reason why we're focusing on road transport for the purpose of this paper is because for you to transport hydrogen by pipeline, you need to build an entire pipeline infrastructure network. The existing pipeline infrastructure network that we have for natural gas, it took about 30 years to get it to this level. Now, if you wait 30 years after you produce hydrogen to transport it, then of course the economical value will be lost. That's why we transport it by road. But hydrogen blending is a very good idea, because if you blend hydrogen with natural gas, you can lower the flammability and make it easier to transport. So yes, that's an eventual way of transporting hydrogen. But right now, I believe the best way to transport is by road because of these considerations.
All right, thank you very much, Campbell. Thank you for that wonderful paper presentation, and thank you, our wonderful audience, for staying behind. So we just have one more thing for you. We have someone to win our prize. We have a game. We just talked about a safer way to transport gas. So we're going to play an ESG game. Let's see how safety conscious you are. So we're going to put up a QR code. All you need to do is scan the QR code, start the game, and we look out for the top winner. Let's have the QR code, please. Or do we have the hard copy one that was okay, all right. So just scan the QR code and start. It's time bound. Make sure you give yourself a name. Just points, like capture sorry?
Says thank you for playing. I don't know.
No, you've not started yet.
When start? Just
You have the thing. You have not started, so you click start here.
this starts.
Yes, and then you have to touch. When you start, you touch all the unsafe acts. I hear someone clicking already. Make sure you don't lose your score when you're done playing. If you have to screenshot it, do so. Make sure you don't lose your score when you're done playing. Sorry? No. What's your score? If you're done playing, we need to know your score. Is yours ended? What was your score? 8. 8? Okay. 6. We have 8. What did you score? Huh? 9. Okay. 8. Can I see your 9? 16. No, no, no. That's not your score. No, that's not your score. That's the highest person that has scored.
They won't leave me come out. Give me the mic.
Oh, sorry.
Mike, don't leave me come out.
Please, those that said they have 9, can I see your score? I need to see your 9. Yes? Yours is timeout. That means you've not played yet. 8. So,
You don't start now.
I make a no be one.
Exactly. Give me my go. Don't give me your bag. I carry your bag. Go. Give me your bag.
Oh yeah, remove them now. Put them back.
I carry everything there.
All right, so okay, we have an 11 and 9. Huh? It's saying timeout. I'm not seeing your score. Okay. Okay, we have another 11. Okay, 11 and 11 come out. 11 and 11, please come forward. Where is our guy? You showed me 9 earlier. How did you get to 10? But you showed me 9. That means you played again. Okay, 11 and 10, please come forward. 11 and 10. I better get me with souvenir, yeah.
So I'll be 10 now.
Yes, be hopeful. We know there's second one gift. You have a second one. Anything. Whatever you have available.